Welcome to mathematics class. In this video, I'll be talking about transposition and special matrices. The special matrices that we have are symmetric matrix, square matrix, and null matrix. Now let's move to transpose of a matrix. Suppose you have matrix A to be equal A11 and A12, then A21 and A22, right? In this case, you are asked to find A transpose. Transpose now, I can simply write this as A11 and A21, and this as A12 and A22. In this case, what I simply did is that I replaced the row with the column and the column with the row. Right? So it actually indicates the transpose of a matrix. Whenever you are asked to find the transpose of a matrix, the transpose of a matrix is taken to be the interchanging of the row and the column. So now, without wasting our time, let's see some questions under it. Let's say you are given that matrix A equal 3, 8, minus 4 and 5. Then you are given that matrix B equal minus 4, 7, 3 and minus 5. Then you are asked to find, or you are asked to simply, let me just put like this, show that A plus B transpose equal to A transpose plus B transpose. So what I'm going to do in this case is that I will have to find my A. I can start in whichever side. I can choose to start from the left hand side or to start from the right hand side. So what will happen in this case is that A plus B, my A plus B is going to be, that's 3 minus 4, 8 and 5. Then plus minus 4, 3, 7 and minus 5. Right? And which is equal. So it's equal 3 plus minus 4, that will give you minus 1. 8 plus 7, that's actually 15, right? Then minus 4 plus 3, that's actually minus 1 again. Then 5 plus minus 5, that's 0. Right? So in this case, it shows that this is my A plus B. Now let me go ahead and find A plus B transpose. Finding A plus B transpose now, I'm going to have minus 1, 15 and 0. That is, I simply replace my row with my column and my column with my row. Then, since A plus B is equal to this, then let's go ahead and verify if our A transpose will be plus B transpose will be equal to A plus B or transpose. Now, the first thing we need to do is to find our A transpose. Finding A transpose here, A transpose will simply be, that's 3 minus 4, 8 and 5. Right? Then our B transpose equal minus 4, 3, 7 and minus 5. Then let me simplify A transpose plus B transpose, which is equal, that will be 3 plus minus 4, which is minus 1. Right? Minus 4 plus 3, that's minus 1 again. 8 plus 7, that's 15. And 5 plus minus 5, that's 0. So it shows us this answer is actually equal to this answer, which is minus 1, 15 and 0. So in this case, I verify that my A transpose plus B transpose is equal A plus B transpose. So what you actually need to know as far as transpose of a matrix is concerned is that transpose of a matrix is involved the interchanging of the row and also the column of a matrix, and it is only applicable for any matrices that has the same order. That has the same order of matrix. which is the same row and same column. So the next special matrix here is the symmetric matrix. Then suppose we have matrix A to be 3 minus 2 minus 2 and 1. Right? And you are asked to find A transpose. Finding A transpose simply means you'll be interchanging the row with your column, which is 3 minus 2 and minus 2, 1. So if you check these two cases, what do you note? Is there any differences between A and A transpose? Since there is no differences between the order and the elements in A and also the elements in A transpose, that means our matrix A is said to be symmetric matrix. Matrix A, any matrices is said to be symmetric if the matrix is equal to the transpose of the matrix. That is, whenever you have matrix A and you find the transpose of matrix A which is equal to A transpose, if they are equal, that matrix is said to be symmetric. So when a matrix is equal to its transpose, it means the matrix is symmetric. Another special matrix that we have is the skew symmetric matrix. So in skew symmetric matrix, suppose we have matrix A to be equal 0, 2, minus 3, minus 2, 0, and 5, 3, minus 5, and 0, right? Then let's go ahead and find the A transpose. The A transpose is given as 0, 2, minus 3. Then we are having minus 2, 0, 5. Then the next one, 3, minus 5, and 0. Is there any differences here? Yes, there is differences. But the differences is based on the sign. If we want to consider the sign, we can see that they are different. Right? So what we are going to do is that we go ahead and multiply our A by negative, because the sign that actually indicates the differences here is the negative sign. So multiplying this by negative, we are going to have it to be, that's 0 plus 2, then minus 3, we have minus 2, 0, and plus 5, we have 3, we have minus 5, and 0. So as you can see, our negative of matrix A is equal to A transpose. Both are the same. So since both are the same, this actually indicates skew symmetric matrix. So a matrix is said to be skew symmetric if its transpose is equal to its negative. That is, a matrix is said to be skewed symmetric if its negative is equal to its transpose. Now let's move to the next aspect. A matrix with equal number of rows and columns is called a square matrix. Let's say we are given matrix A to be 3, 1, minus 3, and 2. This matrix is said to be a square matrix if it has the same number of row and column. Right? Checking the row here is actually the same thing as what? As a column. So this is known as what? Square matrix. And this type of matrix is of order 2, which is 2 by 2. That is, the row and the column are equal. Then let's say you are given 6, 8, 10, 0, minus 2, and 1. Then 3, 2, and 1. So this is also considered a square matrix because it is of order 3 by 3. That is, it has the same number of row and same number of what? Of column. So after that, let's move to null matrix. Null matrix. A matrix is said to be null if it has a 0. Or let me just say, if all its entries is 0. That's a null matrix. For example, let's say you are given 0, 0, 0, 0, 0, 0. What type of matrix is this? This actually is a null matrix